implement a queue data structure in Java. So what is a queue? Well, a queue is a first in, first out data structure, which means that the first piece of data that went into the queue will be the first piece of data that comes out of it. It's kind of the opposite of a stack, where you stack things up one on top of the other, and then the last thing that went in will be the first thing that you take out. It's the opposite to that. So it's a first in, first out data structure. And I've got some tests lined up here. These won't compile yet because we haven't created the class. So what we're going to do is create bare bones of the class, and then we'll start writing code to pass these tests one by one. We know we've got a functional queue if we can pass all of these tests. Okay, let's get to it. So first up, we need to define the class. So public class queue, and we're going to be using generic typing, which means that we have this type T here. And when you create an individual queue, when you construct a queue, we can decide what we want the queue to hold, what type of data. This keeps it really generic. So you might construct a queue with to hold integers, you might construct a queue to hold strings, or maybe some other type of object completely. But by putting T here, it keeps it open and allows us to decide for each queue that we create what type of data it's going to hold. And a queue needs a few different fields. The first one is actually going to be a nested class. We're going to hold a class inside this queue called queueNode, also of type T. And the queueNode is essentially the wrapper for the data that we're going to put into the queue. So what we do is when we want to put data into a queue, we will create a new queueNode, add the data to the queueNode, and put the queueNode into the queue. And the reason we do this is because the queueNode is going to hold not just the data, but also another field called next, which is going to point to the next queueNode in the queue. And this way we can keep track of what order the queueNodes are in, and what order the pieces of data were put into the queue in. We can keep track of where the front of the queue is and where the back of the queue is, and so on. So we need the data, private T data, and we also need to hold a pointer to another queueNode of type T called next. And other than these two things, our queueNodes need a constructor. So let's do that one now. Now when we create a new queueNode, we need to tell it what data it's going to hold. So we need to pass some data to it. And then what it's going to do is it's going to push that data into its own data field, this one here, like so. This.data equals data. So this.data refers to this field here, and then the data on the other side of this refers to the parameter that was passed in. And for good practice, we're also going to set next to null. So now we have a queueNode class nested inside our queue, but our queue needs a couple of other fields as well. We need to keep track of the front of the queue and the back of the queue. So let's create two more pointers for this. Like so. We have the front and the back, so this is going to keep track of our of either end of our queue. Right. Let's create a constructor for the queue now. And when we initialize a new queue, we don't really need to give it any information. It's just going to be an empty queue when we start off. And so what we need to do is set the front to null for now, and the back to null, and that's it. So our new queue is completely empty, and we know it's empty because the front of the queue is null. There's nothing at the front of the queue. Likewise, there's nothing at the back of the queue. Okay, so moving on from there, we need to think about our methods now. So this queue class is going to have 4 methods, and these methods are called push, pop, peek, and isEmpty. I'm going to write out the bare bones of push and pop first of all. We'll fill them in properly later, but we want to at least make sure that our tests compile, so we need to have these methods at least declared and written out, if not fully implemented. So first of all, public void push. Now the aim of push is to push some data onto the back of the queue, and if we're going to push some data onto the back of the queue, we need to know what we're pushing. So we need to pass to it the data that we want to push onto the back. Okay, because this is a void return type, we don't need to fill it in right now, it will still compile. So I'll come back to that one. Tell you what, let's write a nice little to-do note. Next up, we need pop. So public t pop. And the job of pop is to take the front piece of data off of the queue and return it to the user. So it's returning type T, the data, and we need to actually write some kind of return value in here. So first of all, I'm going to write to do so that we know that we need to come back to this one, but we are also going to write return null for now, because although it's not what we want it to do, this will allow it to compile and therefore allow our tests to run. Okay, so push and pop we're going to come back to because they're a little more complex, but the last 2 methods are called peek and isEmpty, and these 2 we can write on the spot. So first of all, peek. Public t peek. Now peek is really similar to pop. However, whereas pop takes the front of the queue, the piece of data at the front of the queue, off of the queue and returns it to the user, peek is just going to have a look to see what's at the front without removing it. So the difference here is that we don't actually affect the queue in any way at this point. So this is a real simple one to do. We need to return, and we're simply returning the front, what's at the front of the queue. However, this will give us a type mismatch error because, type mismatch, because front is a queue node, but this needs to return type T, the data inside that queue node. And the way we do that is by going to front, and we go front dot data to access the data field inside it. Okay, so that's all we need to do for peek. It just simply has a look to see what's on the front of the queue and returns that piece of data for the user to see without actually removing it from the queue itself. And the last method is a bit of a helper method, and it's called isEmpty. And this is of type Boolean. Now Boolean data types are either true or false. They have 2 possible values, true or false. So isEmpty simply tells us if the queue is empty or not. So this will return true if it is empty, and it will return false if it's not empty. Now, how can we tell if the queue is empty? Well, one surefire way of telling if the queue is empty is if the front is null. Because if there's nothing at the front of the queue, then the queue must be empty, because you've got to have at least one thing at the front of the queue for there to be a queue in the first place, right? So we are going to return front equals null. And this statement here, if it's true, then the queue is empty, and isEmpty will return true. If it's not true, it means there's something in this position front here, and the queue is not empty, and it will return false. So we have all 4 methods at least written out with the bare bones of what's needed. so that they can compile in QTest. So now let's run the tests and see if any of these tests pass. Moment of truth. And as we would expect, some of these tests have failed, but this has passed, this one here. So this test is called new queue should be empty. And yeah, this has passed because we've written our isEmpty method. We've written the constructor for the queue, and we've made sure that when we create a new queue, that queue is empty. So we've dealt with the first one. Next, we need to make sure this passes. Push should add item to empty queue. And the reason this doesn't pass is because the method push hasn't been implemented. Although we've written out the bare bones of this method, we've not done any implementation. So when it's called, it doesn't do anything. It has no impact, and therefore doesn't affect this in the way that it should. So let's go and implement push now. Right, so push has two different scenarios. First of all, we want it to behave one way if the queue is empty. And secondly, we want it to behave another way if the queue is not empty. So these are the two different scenarios. It needs to do something slightly different depending on which of these is true. So let's write an if statement here. So if is empty, see, this is where that isEmpty method really comes into its own, because we can just simply write isEmpty rather than having to have other people that read our code work out what we mean by if front equals null. In fact, in the end, once we've implemented this, having isEmpty here, you might argue, means we don't need this comment because it's obvious. But we can come back to that shortly and deal with that. So if the queue is empty, what we need to push to do is to take this piece of data passed to it in the parameter, wrap it in a queue node, and push that queue node into the front position of the queue. So have front point to it. Okay, so first of all, let's create a new queue node. And actually what we can do, rather than doing it that way, what we'll do is simply say front is going to point to this new queue node. And it's going to have the data that we passed as its parameters, so it's going to hold that data. So now this one line of code is a little simpler than what I was going to do, because it just simply says, right, the front is pointing to this new queue node with the data in it. There's one more thing we need to do, which is take the back pointer and have it point at the same thing as front is pointing at, which is this new queue node. And that's it. That's all it needs to do. Quite simply, from here, we've added a new queue node into the empty queue, made sure that it is registered as both the front and the back of the queue. Because if you think about it, if you're the only person in a queue, you are both the front of the queue and the back of the queue. Okay, so what if the queue is not empty? So here we need to keep track of, if there's something in the queue, we need to find the thing at the back of the queue and keep track of that, because we're going to replace what back is pointing at with something new. But at the same time, we need what was at the back to point to the new thing that is now at the back, so that we can keep track of which order they are all in. So this time we need an else. Oh, not quite sure why it did that. Let's try that again. Else. That's better. And here we need, first of all, to have something point to what used to be the back, so that we can keep track of what used to be the back, even when we've changed what this pointer here is pointing at. So a new QNode pointer called old back, and it's going to point at the same thing as back. Right. So now we're keeping track of where the old back position was. We now need to change back and make back point to this new QNode with the data in it. So back equals new QNode with the data in it. This line essentially does what this line here does, except up here, because the queue was empty, we're putting this new QNode in right at the front of the queue, whereas here it's going to be the back of the queue, but it's not going to be the front of the queue. And now we need to connect what used to be the back to the actual back, or at least connect the back to what used to be the back. So each QNode has a field called next, you might remember, and so next points to the thing that's behind it, and so this needs to point to back. So oldback.next needs to point to the thing that needs to be behind it, which is back. And that's it. So we have a new QNode pointer called oldback, which is going to point to what used to be the back. Then we're going to change what the back is and make it this new QNode with the data in it. And then we have what used to be the back. Its next pointer is going to point backwards to the new back of the queue. So let's try and test that now and see if it works. And let's see what we got. Let's just close this one for a second. Excellent. We can see 2 tests have passed. We've passed push should add item to empty queue, and new queue should be empty still passes. That's good. So next, push should add item to back of queue. Let's check this one, because there seems to be an issue here, because push should add an item to the back of the queue, because that is what this bit, the else part of this, does. We know that this is working because this is the bit that push does if the queue is empty. So push should add item to empty queue. It is doing that. But push should also add item to the back of the queue, and it's not doing that at the moment. Now, I think the problem here is that we haven't written pop yet. So this test has a slight flaw in it, because not only is it testing that push works, but it's also testing this other method, pop, quite necessarily as well, because the only way we can test whether this extra piece of data here has been added to the back of the queue is by removing the piece at the front and seeing if this one is behind it. So we do actually need to make pop work in order for this test to run. So let's implement pop next, and we'll see if that fixes our problem. So Right now pop just returns null, but what we need pop to do is remove the thing at the front of the queue and return it to the user. Now the way we're going to do that is by, first of all, keeping track of what was at the front of the queue before we remove it. And so we need to have something called that I'm going to call old front. It's a pointer to a queue node. Old front, and that's going to point at the front, at the queue node that is at the front. Now that's really important because we need to change what's at the front. We need to remove this item, and the way we're going to do that is by making front point at something else. But if we make front point at the thing that's behind the front first, without logging somewhere what was at the front, which is what we've done here, without making a note of what actually used to be at the front, then we lose track of what was at the front and we can't return it to the user. So that's why it was important to have another pointer called old front, which points to the same thing as the front, because now we're going to change what front points to. It's going to point to the thing behind the front. And how do we see what's behind the front? We use the next pointer from the next field inside the queue node. Okay, so we've affected the queue. We've changed the queue so that the second item in the queue is now at the front. Effectively, we've removed the front item. We've stored it in old front, and now we need to return old front. But we're not returning a queue node, we're returning the data inside that queue node. So we've returned old front.data, and now let's have a look and test to see if that works. Here we go. And just like that, everything passes. So new queue node should be empty. That still works because we've set up is empty, and we set up the constructor for the queue node, and then the queue, sorry. Push should add an item to an empty queue. That works before, that still works. But now this test, which wasn't working before, push should add item to back of queue, is working because we've implemented this pop method. And similarly, pop should remove item from front of queue is also working. So all of our tests pass, and we have implemented a nice simple queue in Java. Thanks very much.